In this video, we'll continue our discussion with polar integration with another example. Finding volume below, the surface z equals y over x squared plus y squared above the xy plane. This is very important. And between the circles x squared plus y squared equals 1 and x squared plus y squared equals 3. I drew those circles. Be very careful. The radius of that second one is root 3, not 3. We're trying to switch to polar, so let's just write down the function first to get us an idea of how to work with this. So this would be just like that, dA. Okay, a couple things I want to think about because we're trying to set up some r's and some theta. So we want to go to polar because it's a circular. What we're trying to find, if you're unsure, is we have a surface that can live across all the xy plane, but we only want the volume under the shaded part there. So this would be some kind of circular surface above the xy plane, and we only want the volume above it. So let's deal with our r's first. If I take this and solve for r squared, right, I would plug it in, I got 1. Solve for r, I got 1. The second one, I got r squared equals 3. So that means r is equal to root 3. So this bounds my r for me. My r is between 1 and root 3. We can see that here. The radius is between those two. Now our theta is going to be a bit tricky. If I look at the picture, I'm like, oh, cool, 0 to 2 pi, for sure. But this thing throws a wrench in that. Think about the function that we have here. The denominator, x squared plus y squared, will be always positive. So if I want z to be positive, we need y to be positive. If y is positive, z is positive, which means it's above. But if y is negative, then z is negative, and that's just because the denominator doesn't affect the sign. It's always positive, and the only thing that affects the sign of z is that y. So even though it feels like we should do 0 to 2 pi because of our picture, notice that up here, as long as y is positive, the surface that's inside of here will be sticking above the xy plane. It'll be above it. But down below, the y is negative, so down here, it would be below the xy plane. So we really only need that top half. So that's going to be 0 to pi. I would challenge you to do 0 to 2 pi and see what you get and try to make sense out of why you get that answer or think about it. All right, so let's go ahead and convert our integral. We know our thetas always go outside, so it's 0 to pi. Our r is from 1 to root 3. And then we convert our integrand. So we got to convert it in terms of polar. So I got r sine theta. Be very careful that you pick the right one and not cosine here. It'll totally throw you off. X squared plus y squared is r squared. And then to convert, we do r dr d theta. Cool. All right, let me move this out of the way because I have a feeling I'm going to run into it. All right, I keep going. I'm just going to simplify first so you can see all the r's cancel out. That's very nice for us. So we get an r make r squared. Over r squared, it's gone. Okay, so I get sine theta dr d theta. Now we're going to integrate. Okay, the integration for sine theta in respect to r is r sine theta. Be very careful not to sit there and try to, get cosine here, negative cosine, because it's with respect to r, not theta. So we're going to run r from 1 to root 3 of d theta. So theta is equal to 0. We're running the integral from theta to 0 to pi. And then we're just going to plug these in. I want you to, if you need to plug it in each one and subtract them, I'm going to show something, see if you can make sense out of it. We're just going to get the root 3 minus 1 of sine theta. Right? I'm not plugging r into anything, into sine theta, so that's going to stay in both terms, and then I just factor the sine out. This is just going to help us in this next one. I don't want to do 2 of them. I can just do 1. Now I can integrate that. I get the constant. I could just pull that outside. And then the integral of cosine of sine is negative sine. So I'm going to put negative cosine, sorry. Integral of sine is negative cosine. I put the negative out front. And then I'm going to run theta from 0 to pi. Be careful here because plugging this in. Okay, I'm going to pull out that constant. All right, and then I have cosine of theta, and I'm running this from theta equals 0 to theta equals pi. And it's kind of weird writing it that way, but I just want to show that the constant just stays out. So I get the negative of root 3 minus 1 times, okay, it's going to be cosine of pi minus cosine of 0. I got negative root 3 minus 1. I got negative 1 for cosine of pi minus 1 for cosine. That's a negative 2. That cancels with the negative out front. And I get 2 times the root 3 minus 1 for my exact answer. So that is the area above. Like I said, I would challenge you to do 0 to 2 pi and ask yourself, why did the answer for that come out? And it's not the same. I'm going to tell you it's different. You could probably, some of you guys can probably put it together just looking at the region and thinking about that y value that was in the numerator. But like I said, I challenge you to do it 0 to 2 pi and think about why did it not work that way.